We are starting from the title magnetic field due to a current carrying conductor. This is a straight current carrying conductor. So you have to start from here. Okay. So magnetic field due to a straight current carrying conductor, like this is a straight wire. This is a straight wire and it is carrying current. So magnetic field due to a straight current carrying conductor. We are putting our first concept, that how we identify that magnetic field is present in any system. What is the most common tool to identify magnetism is there? Compass. Very good. So from here we are starting. So please note this. So everyone, please look at the screen. The title is magnetic field due to a straight current carrying conductor. This was the heading. So everyone, please locate the heading, put the first concept, write down the first concept, that a magnetic compass can be used. A magnetic compass can be used to a magnetic compass can be used. A magnetic compass can be used to show. A magnetic compass can be used to show magnetic field around a current carrying conductor. A magnetic compass can be used. A magnetic compass can be used to show magnetic field around a current carrying conductor. Around a current carrying conductor. Now, if you people can recall, if the current is in a straight line, look at the screen. If the current is in a straight line, if the current, look at this diagram, if the current is going in a straight line, what is the direction of the magnetic field? If the current is going in a straight line, the magnetic field is, I'm not saying positive, I'm asking the geometry. Look at this geometry. Circular. So this is my concept to be back. When electric current passes through a straight conductor, the magnetic field produced is circular. So you have to write now in the next line, when electric current, next line, when electric current passes through a straight conductor, when electric current passes through a straight conductor, a circular magnetic field is produced. A circular magnetic field is produced, comma, with a circular magnetic field is produced with increasing separation, with increasing separation with increasing separation between the circles, with increasing separation between the circles. This is our second concept for today. बताओ आज का पहला concept क्या है? What's the first concept for today? Whenever you want to show that magnetism is there in a region, what is the most common thing you can use to show that magnetism is present? In order to show the magnetic field, you can use magnetic compass. What is our second concept? If current passes through a straight conductor, the circular magnetic field is produced, and these circles have increasing separation. Circles get away from each other with increasing separation. In the exam, they will be expecting that you people will be drawing good, neat circles. I mean, compass level circles should be there. As usual, they are overreactive. So now, this is a straight wire. Magnetic field is in circular form. and the circles are with increasing separation. Now you have to copy this diagram neatly. Neatly means circles should be drawn carefully. Separation between the circle is increasing. You have to copy this. These are the first two concepts for today. Whenever a wire, beta ruk jao please. Whenever a wire is straight, a circular magnetic field is produced. The circles are increasing in separation. Now I'm putting my next concept. Look, if this is the wire, look, this is the wire, this is my y-axis, this is my wire. The circles will be produced around it on this axis. So if this wire is on y-axis, my circles will be on the x-axis. It means the circles which we are drawing, these circles are always with 90 degree. In other terms, the circles are perpendicular to the wire. So now you have to change the line. You have to write down a very famous thing in our O level, and everyone will remember it when he sees it. Everyone will remember it when you see this thing. I think you recall this famous name in our O level. It was very famous. Fleming's right hand rule. So you have to now copy this screen. Fleming's right hand rule. Give a side heading, not a main heading. Main heading is the same through a straight wire. You have to copy this. Do not use mobile phone. Do not, please focus on the screen. Fleming's right hand rule. Now recall this. Now look at the diagram. You have this wire. Look, this is the wire. You have to hold the wire in your right hand in such a way that the thumb is pointing in direction of current. The fingers will be in the direction of, again, the thumb will be in the direction of current, and the folded fingers, they will be showing the direction of. So either you're going to hold it like this, or yes, you're going to hold it like this. Who can recall this in O level? Yes, recall it. Very good. Yes. And यहाँ पर, do you recall it? O level. This is the way the thumb shows current, and folded finger shows. Now, if I hold it like this, if you people hold your pen like this, and you people tell me if the current is going upward, is it clockwise or anti-clockwise? My fingers. You do it on yourself, not on mine. Do it on your anti-clockwise. If I hold it like this, clockwise. Good. This is the concept. Now, right under it, after giving the side heading Fleming's right hand rule, right under it, that hold the wire in your right hand. Hold. हाँ, ये इसका पूरा नाम होता था. और ये वाला नहीं, वो भी राइट हैंड, ये भी एक और भी राइट हैंड अभी आएगा. देयर आर 3 राइट हैंड्स. ही वाज फ्री नॉट, फ्लेमिंग वाज टोटल, क्या बोले रिकॉर्ड. सो अभी कुछ कमेंट बाद में करते. बट उसने कितने रूल्स बनाए थे याद आपको? लेफ्ट हैंड राइट हैंड टोटल कितने थे उसके? 4 थे. शुक्र करें उसको पैरों का ख्याल नहीं आया, और मुसीबत होती क्लास में पांव ऊपर रख के बैठे रहो. सो एक्चुअली दिस वाज, बट दे रियली लाइक इट. स्टिल इन ए लेवल, यू पीपल वोंट बिलीव, फ्लेमिंग इज अ term, Fleming is a name here which they like a lot. If you write in the exam that I found this direction according to Fleming right hand rule, they will be extremely happy. बहुत खुश होते हैं if you refer to Fleming rule. Okay, now look at this example. Look at this example that sorry, I missed it. Look at the example here. Hold the wire in your right hand, right under it. Hold the wire in your right hand such that hold the wire in your right hand such that the fingers, such that the thumb, hold the wire in your right hand such that the finger is pointing in the direction of current, such that the thumb is pointing in the direction of current, such that the thumb is pointing in the direction of current, comma, the folded fingers will be pointing in the direction of magnetic field. The folded fingers will be pointing in the direction of magnetic field. This is, as I think Adil said, someone said that this is called as what in our O level? Right hand grip rule. And the right hand grip rule has two options. Okay. Now remember the concept from our O level. If the current is upward, the magnetic field will be anti-clockwise. If the current is downward, the current will be. But as I was explaining, you people have to remember that they want to hear this name. So when they ask how you know the field is clockwise or anti-clockwise, you have to mention this. Yes, this name. There's a dash before him, but so now we have. So now next line. You have to change the line and you have to go for another O-level good memory. Achha, this is my way of going because I do not keep things open ki haan bhai, you can go and read O-level and reconnect it because everyone is so busy that it's always difficult for everyone to go and reconnect O-level. These things I am connecting here are O-level things, our IGCSE or GCE things. My benefit is there, but I can do it here. You people have a connection. Obviously, the time loss is there because if I just go for A level, I can finish it more quickly. But this chapter is my biggest chapter of course. It has lot of dots connecting from O level. Another dot, front view and top view. So when you people are sitting looking at the projector screen, you call this option as something fall and you look at like this. This is called top view. Any example of top view? Like Pakistanis have a very nice way of opening a jar and looking in the toffees or something and take it out. Any experience of this thing? In your home, if you have a jar of toffees or a box of toffees, you open it and you look from the top. From the top means it's basically like this. It's a perpendicular view. And what is front view? What is front view? When you're looking at this projector screen, this is called front view. So when you look at like this is called top front view. And if you look at like this is called answer top view. Please do not make jokes on that. This vision is called front view. But if you look something from the top, then there are two options. There used to be two options. One was in the page and second was, achha, this is a rod. If I look the rod like this, what is this? Front view. Achha, if I look from the top view. If the current is coming towards me like this, out of the page, if current is going inward into the page, good. So now these are the conventions you people have to recall. So right under it, there are two orientations of vision. There are two orientation of vision. There are two orientations of vision for measurement. There are two orientations of vision for measurement. Number one, front view. Number two, top view. Number one, front view. Number two, top view. Now, front view is clear. When you drive a car, you look at the screen, this is front view. When something fall, you look down, then it comes the top view. There are two versions of top view. What are the two options for top view? Yes. Now you have to copy this. One was dot and one was cross, and I'm very hopeful that you people are getting this memory back from O level. Dot and cross. Dot and cross. Now comes in the diagram. Look at the screen. Now this is a wire. I have written current is into the page. What's the meaning of current into the page? Like if this is the wire like this. If current is going this way, it is in the page. If current is coming out of the page. Here, look at the cross. Look at the cross. The meaning of the letter cross means into the page. Now you have to remember your hand. Okay, now you were holding it like this. Now there are two options. If you are doing this pattern, you can put it like this. Thumb is on the table, or you put it like this. Everyone, put your hand like this. Everyone, now do it. तो मैं कह रहा हूं टेबल पे हाथ रखो ना. हाँ, यहाँ रखो. Good. That's a good style. Now look at this. Thumb is pointing out of the page. Your fingers are giving clockwise, anti-clockwise. Anti-clockwise. Now move your hand and gently put it like this. Good. Now remember, you have to use your right hand. Okay. Now look at this. The thumb is pointing in the page. This diagram is pointing in the page. When you copy this diagram on your copy, not on the board is perpendicular to our vision presently. First, you copy this on your notebook and then put your hand like this to see the direction of the field is what? Good. So I repeat my wording. So first, you people copy this. Again, can you people notice that separation between the circles is increasing? Separation is increasing, right? Okay. Everyone, now you people have copied it. Now everyone, please put your right hand on this diagram, not on the board, on your copy. Show me how you people can put your right hand and see the direction of the magnetic field. Good. Very good. Your right hand on the copy. हाँ, it's your own right hand. शाबाश. Very good. ये तो पूरा screwdriver लगा है. Good. Now look at the next diagram. Can you see what's happening here? It's a dot. Dot means out of the page. Here, you have to put your hand like this. This is one of their favorite diagrams which come in the exam. You people have to remember that you people should be using compass, plus you people should be using which rule? Right hand rule. They will be waiting that you will write that I got this answer according to right hand rule. They will be asking you the direction of the magnetic field. They can ask you what will be the direction. So now you have to copy this again. I repeatedly saying neat drawing. Separation should be increasing. So copy this. No discussion, please. What? Huh? इसको ये वाला राइट हैंड में he has no वो एग्जाम तो कोई नहीं उसका. खैर अभी we are on recording, so be careful, then we can condemn him later. Now you have to make a neat drawing, and after drawing put your right hand to show me how you can find the direction of the magnetic field. Right hand. Copy the diagram, no mobile, copy the diagram, and now copy. After copying it, put your right hand and show me how you can find the direction of magnetic field. Okay, so this is the direction. Now we introduce a formula. A2 is loaded with formulas. And yesterday, I think, yesterday was the paper 4 retake version. And people were saying that it was a library of formulas. No main formula is given. You have to remember the formulas. Lot of calculation is there. A2 paper, whenever you see the past paper, we have a pending homework right now, which I'm reminding also. Electric field, AS version and A2 version. Remember that A2 is a memory test. You have to remember all the formulas. Some formulas are there which are always given, like this formula. This formula will be given. It's not a memory for the student. Now look at the formula. Magnetic field strength is equal to mu naught. What this symbol is read as? This symbol is read as mu. Mu naught upon 2 pi r. What the letter B stands for? Magnetic field strength. Letter I, current. Letter R. Now here comes the new letter mu naught. What mu naught stands for? Permeability of, and the unit is very funny. The unit is Henry per meter. So this is actually the formula which we can use here. The formula says that how you can calculate the magnetic field strength around a straight wire. Mu naught I upon 2 pi r. Okay, now you have to copy this. Remember, this formula will be given. It is not part of the formula in memory. Do you people remember the formulas like Kepler law? They are in memory. Their derivation is also in memory. Some formula like Newton's law of gravitation are in memory. There are some formulas in A2 physics which are called qualitative formulas. They won't ask you to write it. They will write it. You are supposed to just use it. What's the value of mu naught? 4 pi into 10 power -7. Acha, this value is given in the exam. Let me mark it here. Or majority important constants are given in the paper. Even the constant k, epsilon naught, and other constants are also given. Their main problem is the formulas. They do not give all the formulas where the problem actually comes in. Now we introduce back one of our important title. Everyone who has a memory, everyone who has a good memory of O level, he or she must have understood that we are connecting with O level and we are inputting the A2 also. Like this formula was not in O level, but the concept of this flaming left hand rule, this one, was it there in O level? This one, it was there, na? So this is how we are moving, and you people have to cooperate and you people have to support me to refresh your memory. That's why my time, your time will be utilized, because we have to reconnect all the necessary things from O level. So I'm now asking you, do you people remember this very famous thing in O level? Solenoid. If you take a straight wire like this and you coil it, if you coil a straight wire, it is called solenoid. Very good. So now this is a solenoid. Starting solenoid, give a new heading, leave a space of 2 lines. This is starting a new title within the same chapter. The title is solenoid. What is a solenoid? Repeat. What is a solenoid? What is a solenoid? Everyone on the screen, what is a solenoid? It's a coiled wire. Solenoid is a coiled wire. So when current enter this solenoid, notice that current is going in a circle now. Current is going in a tunnel. Current is going in a circle. So when you draw a solenoid, look at the pattern of current. Current is going in a circle. Very important concept. When current was going in a straight wire, look here. When current was going in a straight wire, magnetic field was circular. Achha, if current becomes circular, then magnetic field will be straight. I am connecting the, again, an important concept of O level. Achha, now you people have to copy this. Neat diagram is needed. Otherwise, after watching the scripts first time in A2, now first time as a teacher, we come to know that why the threshold is so low in paper 4. In paper 4, the threshold is so low. Normally, it goes around 60 out of 100. Why so low? For A grade. Because they react on everything. I mean, I saw a script where a student was writing the definition of gravitational potential, and in the end, the student forgot to write the word that point. Anyone remember the word that in the end of the definition of gravitational potential? Infinity to that point, and that dash examiner got so sad that he made a -1. This is uh, this is horrible. This is horrible in exam if a student forgot to write the word that. Strange. Anyways, no further comments. Move forward. Let's get some liberty. Then we can comment in our style. It's the same grip rule is there, na? Because we hold it like this. There we hold it the same rule. Now, when this, remember a very important concept now, everyone on the screen, please. This is again a consolidation concept from O level. If the current is going straight, magnetic field is, if current becomes circular, magnetic field becomes straight. This is my O level reconciliation. So your people have to remember, copy this box. Copy this important box, O level. So what we are doing, we are putting this chapter connecting with O level. Every concept is connected with O level. We are getting it back and updating it for A2. So memory support is needed here. And if you people, if someone, any one of you is not recalling anything, that person means that he or she is the lucky person, because obviously weak memory is a source of happiness. Now, I have drawn the lines. We used to draw the lines here in A2. They have a strong interest asking the people to draw the lines. Achha, when you draw the lines, he will open his eyes full microscope style and he will see the lines. The lines are not symmetrical. Oh, I'm sad, -1. The lines are touching each other. He's sad, -1. The lines are not equally divided. Again, -1. So as a joke, the minuses are sometimes more than the score the student is getting. I'm not saying they have a negative marking. I'm saying the way they check it, the diagrams is very, very tough. They want people to be very accurate in drawing. Our people are very careless. Our people say, look, this is a line. Student is drawing this line. And then proudly the student is writing in front of the line that this is a, how it can be a straight line. It's a wavy line. So remember, I repeat my important point. Magnetic, electric, gravitational. All these lines are collectively what? Flux. Point number 1. Field lines never cut each other. If you draw and these lines are cutting, the field is gone. Second is the lines should be symmetrical. The lines should be symmetrical. If there is a center line above the line and below the line, it should be symmetrical. Third important concept, these lines are nearly straight inside the solenoid and they bulge out outside the solenoid. I repeat, please carefully remember, the field lines never cut each other. These lines, the pattern should be symmetrical. Symmetrical means what? Suppose this is one line. 1, 2, 3. Okay, then here. Now what's wrong? What's wrong with this? They are not symmetrical. He will be terribly sad and he will do the same in August. Third point. What was the third point? The lines should be nearly straight inside the solenoid. And outside the line, outside the solenoid, the lines bulge out. So these are the 3 important points. You have already drawn the solenoid. Go back in the solenoid and draw these lines neatly. You can go back, you can, if you want, you can draw a new solenoid. I have no objection. But you can go back in the previous diagram and draw neat lines. I don't have a courage to get up and see the diagram, but I hope you people draw a good diagram. Good drawing is needed. You can draw on the previous solenoid. If you want, you can draw on the same, a new diagram also. Homework has to be submitted on physical books. Electric field AS version, electric field A2 version is the homework, and it is due on 25th. You means Saturday is there, but we will have a 1 day for the 1 day for compensation allocation. All. नहीं, the book you have maybe around 10 years maximum. 2017 2016 से maximum होगी है। हाँ तो 10 साल बहुत है, क्वाइट गुड। तुम 16 से रख लो, एक हम एक सेट कर लेते हैं, दैट्स अ गुड पॉइंट। 2016 to 24 कर दो, बट एटलीस्ट कवर 10 years इन राइटिंग। वो बुक नहीं होनी चाहिए विच इज ऑलरेडी फुल, इट्स माय फादर बुक, माय ब्रदर बुक, वो नहीं। पूरी भरी हुई किताब लेकर आओ, जो उसका क्या फायदा। ड्रॉ गुड लाइंस. Now, look at the field pattern. This is the 3D version of the same field. The lines are highly concentrated within the field. Achha, if the lines are highly concentrated, look at this position. Huh? If the lines are highly concentrated here, can we say the field is very strong inside the solenoid? Now look at this region. Can we say the field is weaker here? Good. So now introducing the formula that was not in O level. So I have explained what I'm doing. I'm making proper connection with O level, updating it for my A2. Now look at the formula. B is equal to mu naught Ni. This formula also comes in the category of given. Given means this formula will be given to you in the question also. So now introduce the formula. Now, introducing the top view of the solenoid. Remember the concept solenoid. Suppose this is the solenoid. Look, this is the solenoid. It is on the table and I'm watching it like this. If you are watching the solenoid from the top, if you're watching the solenoid from the top, look at the diagram. What's the meaning of dot? Dot means out of the page. Current is coming out of the page. Acha, cross means current is going in the page. So now this is the top view of solenoid. Again, you have to copy it. Neat drawing. उसको राइट हैंड बना के भेजो ऐसे ना, बस ना अभी कारण उस पर लिख दो 5. This solenoid is on a table and you are watching it from the top. This is the top view of a solenoid. So give the heading for the next class: determination of polarity of a solenoid. Determination of polarity. Polarity means north pole and south pole. Determination of polarity of a solenoid. Okay, so we are stopping here.